Awesome. Let me share my screen. Hi, everyone. This is Amar. Thank you for listening in today. I want to talk about how we can set up an Azure MCP server and be using VS Code for showing that. This is Amar. I'm dialing in from Seattle. So a little bit about myself before we start the session. I'm Amar, as I said. I currently work at Pinterest. I'm working with the infra provisioning team at Pinterest. Prior to Pinterest, I was working at Lacework, and a couple of other startups. At Lacework, I primarily worked on developing this security solution for cloud providers, including Azure. Apart from work, I'm a proud dad of a 4-year-old, and you might see me often making funny reels with my wife. I'm also actively involved in the community where I'm organizing various hackathons. I had a fellow co-speaker for this event, but unfortunately, due to family emergency, they could not attend the event. But to fill about them, Venkat is a lead data engineer at Lashin. Previously, they've worked with Meta, and they are an active tech blogger, and they're also a proud dad to a 8-year-old. Just a brief disclaimer before we start the session. The views, opinion, the work presented over here are our personal opinions and do not represent our employer's work. So this is the agenda that I would like to go over today. Initially, we'd like to see what MCP is, Model Context Protocol. We'll go into the bit details of MCP, what are the different modes, what are the different components involved over there. Post that, we'll see like what Azure offers for the Azure environment as an MCP server. Then we'll dig into a little bit of what the different server modes are for the Azure MCP server. And in the end, we would see like a demo using an Azure MCP server, querying the Azure account with VS Code. I would highly encourage you to follow on if possible. So if you plan to do that, these are the few prerequisites that would be needed. You would need a VS Code editor. I would recommend adding Azure CLI. This is used for authenticating, and of course, a dummy or playground Azure account that you would want to try this thing on. So while we are covering the tech details, if you want to also follow me in the demo, you could also try to install this on the side. So starting on, so what is MCP? So let's dig into a bit details over here. So prior to MCP, this is a typical AI workflow would look like. You usually have an AI app, which could be an IDE like Cursor, Windsurf, VS Code, or it could be a chatbot like ChatGPT or Perplexity and so on. So a typical workflow would be a user is interacting with the AI app with the user prompt. The AI app is then takes the user prompt, massages into useful information. It might add some additional information and send it to the LLM. The LLM is basically then processing this prompt and the additional information that is sent by the AI app, and it sends a response back to the AI app. The AI app would then probably format the response and respond back to the user. Or if it's an ID, it might make changes to the code in our cases. So one problem here with the LLM is that LLMs are limited by certain things. Number one is the knowledge is frozen in time. LLMs are trained only with a certain amount of data and until a certain amount of time. So the responses that we would be getting for them is not tailored for our environments. So if you're an organization that wants LLM to respond to your internal data, or if it wants to invoke certain things on your behalf, LLMs can't do that. So to answer this, there are different techniques used, like RAG is also there. But to make it flexible, Anthropic came up with an open standard design called Model Context Protocol that allows to overcome these LLM limitations in a generic way. So what MCP provides, it provides a standard language for AI agents and LLMs to interact with each other and extend and share this extra information to the LLM. So with this, LLMs can move beyond static knowledge. They can retrieve information from your personal external systems, or they can take actions on behalf in front of the in the context of the AI workflows. So what are the different components involved in an MCP workflow? So because you want to connect to external systems, these capabilities are provided by MCP Server. So MCP Server is the one that is providing this extra information, or it is able to take actions on behalf of the AI workflows. This is exposed by MCP Server. You can imagine this similar to an API server, but that is responding to MCP protocol. On the MCP host, you can imagine this as like an AI-powered ID or the AI chatbot in which the AI workflows are being run. Now, inside these inside these AI-powered IDs or chatbots, the component that interacts with the MCP server is the MCP client. This basically maintains a connection to the MCP server, gets the list of capabilities that is exposed by the MCP servers, and makes it available to the AI-powered ID. Now, if you're talking about the transport layer, the way MCP clients and MCP servers interact is via JSON RPC messages. These could be over STDIO if the MCP server is running locally, or these could be over HTTPS if the MCP server is running remotely. You might need this if you want to if you want to go and see what exactly is happening at the protocol layer. So with this in context, this is how the AI workflow would now change with MCP in picture. So previously we had the AI app. Inside the AI app, the AI app could be an IDE, or it could be our chat agent. So inside the app, we now have an MCP client module that can understand MCP protocol, and this is interacting with the MCP server. That could be running locally or it could be running remotely. So the rough sequence is when the AI powered ID is launched, the MCP client uh, interacts with the registered MCP servers and understands what the capabilities are. This is step 1 and 2, where after this step, the MCP client would know what capabilities are exposed by the MCP server. So in our example, if this is an Azure MCP server, it would know what things we can do in the Azure environment with the MCP server. What information can we retrieve from the Azure environment, or what actions can we take from the Azure environment? These capabilities are provided back to the MCP client. So once the MCP client knows this, any further interactions with the AI app would be embedded with these capabilities. So for example, if a user is sending a prompt to the AI app, when the AI app is sending this prompt to the LLM, along with the prompt, it might also send the list of capabilities that might be necessary for the LLM to serve this request. So in our case, it might send, this is the Azure server that I have, and these are the list of tools or capabilities that are available by the Azure server. So on the LLM side, when the prompt is received, it first checks if the LLM can service the prompt using its own knowledge. If there are certain things that the LLM is not able to serve with this knowledge, it looks at the list of capabilities. This could be retrieving the list of resource groups in your Azure account. So this is specific to your own account. So the LLM wouldn't be aware of this. So in this case, the LLM knows that it has to invoke this particular capability via the MCP server. So in this case, the LLM would respond back to the AI app saying that I don't have enough information. You need to go ahead and invoke this particular capability for the MCP server. So in response to this, the MCP client will send a request to the MCP server using MCP protocol to invoke that particular tool with some set of parameters that might be provided by the LLM or the agent might be having in place. Now, when the MCP server gets this request, it might do a bunch of actions. Some examples could be it might, if it's like, let's say it's an Azure MCP server, it might be interacting with the Azure APIs and fetching that information for us. It might also mean like interacting with downstream API servers and making those calls and returning back those responses. But at the end, the MCP server is doing all the actions that is needed and is returning the response back to the MCP client. This response is then sent along with the original prompt the user had requested to the LLM. So now the LLM not only has the initial user prompt, but it also has the additional information from the MCP server. So with this, the LLM might be able to service the request. If not, it might make further additional calls back to the MCP server or to other MCP servers via the AI app or the AI agent, and eventually it might return a final response. So this response is then returned back to the user, or the AI agent might make necessary changes in the environment. Cool. So let's look a bit further. So this is another view of the MCP interaction where we see like where could the different MCP servers be located. So in this case, you can imagine the outer box as your host, as your machine, your dev server, or your laptop on which you're working on. Inside this, you're running an AI application, which is called MCP host in the context of MCP protocol. You can imagine this as VS Code for our purposes. Inside VS Code, we might be having multiple MCP client sessions that are interacting with different MCP servers. Now, these MCP servers could be running locally, like on the machine itself on which you're running. Some examples might be an MCP server that connects to a local instance of a database running on your system, a SQL database, or it could be interacting with file system in a specific way. Like if you want to expose only certain directories, or if you only want to allow certain operations on the file system, you might use an MCP server that allows you to restrict these operations. So both these MCP servers are running locally. In this case, the MCP client is interacting with the local MCP server using stdio. Like it's invoking the commands, getting the responses from the MCP servers over a standard input output. In contrast to this, MCP servers might also be running remotely. In this example, we might have an MCP server that is running in an Azure or GCP or AWS account, and your AI application, the IDE, is interacting with this remote MCP server. If you're, let's suppose you're trying to code something or you have a pull request, you might use a GitHub MCP server to fetch information about the latest PR on the branch you're working on. In this case, GitHub provides an MCP server that you can connect to you using a GitHub credentials. So with this in context, let's see what capabilities are exposed by Azure MCP server. So Microsoft has this open source MCP server, which allows you to interact with Azure. What this allows you is to supercharge your AI workflows with the Azure context. So if you're maybe developing Terraform code, for example, or you're writing ISC code for provisioning Azure resources, and if you want to bring in the Azure context to your AI workflows, like finding out what resources do you have, finding out your IAM policies, you might want to empower your AI workflows with the context of your Azure accounts. So in this case, you might want to use an MCP server as part of your development. So currently the Azure MCP server supports around like more than 40 Azure services. Some examples could be like Azure Storage, Azure Kubernetes Services. There are some Azure Terraform best practices, and so on. And each of these service might have different tools under them, which allows you to interact with the service in a particular way. For example, Azure Storage might have a bunch of tools that allows you to list all the containers. Uh, it might allow you to upload certain files onto the storage. It might allow you to modify the storage properties. So this is all provisioned by the Azure MCP server. Now, some more details about the Azure MCP server. There are different modes in which you can run an Azure MCP server. Um, by modes, there are different configurations which you can set in the MCP server, and we'll look at this in detail a little bit in a few minutes. Like some of these could be like you could select only certain services that you want as part of your AI workflows. For example, if you know that you're only going to interact with the storage service, you want to disable all the services, you could do that. Or if you only want read-only mode for the Azure MCP server, like you do not want your AI workflows to make any modifications to your Azure account subscriptions, in that case, you might want to start the Azure MCP server in a read-only mode. Also, there are some capabilities that are exposed by the Azure MCP server that will prompt for explicit user confirmation if the server realizes that it's handling sensitive data. Now, if you're using AI-powered IDs and if you have Azure CLI already installed, your ID might be able to interact with the CLI as well. So why would you choose MCP over CLI? One thing is that MCP offers richer semantics than text. By this, it means that AI agents, if you're using like ID in the agent mode, and if you want them to interact with LLMs going back and forth, um, if you want certain protocol, like the communication between the AI agents and LLMs would be in a um, specified way using the MCP protocol than using the ad hoc STDIO output of the CLI. Also, if as we saw that you could install an MCP server remotely, this could be used if you have a central MCP server that is used by a team. In this case, you could have observability embedded in the remote MCP server, which allows you to see like which tools are being used. You could add some auditing at that level as well, which you would not get if you're using a local server or a CLI. So these could be some of the reasons why you would want to use MCP. So let's look a bit into like the different modes and you can launch in Azure MCP server. So as we covered earlier, you could either have an MCP server running locally on your own system, or you could host the MCP server remotely. So following the same logic, if we can either host our Azure MCP server locally, that is on the dev machine or the laptop that you're working on, you could have an Azure MCP server spawned in different modes, or you could host it remotely in an Azure account as a container and available to be connected with through different clients. So in today's session, we are going to cover local modes. That should give us a good taste of how what capabilities are provided by Azure MCP Server. So these are the different ways in which we can launch the Azure MCP Server locally. One is using a VS Code extension. This is primarily used if you're using VS Code as your IDE. Now, if you're using different IDEs like Cursor, Claude, um, then you might want to use Docker, which spins up a container that is provided by Microsoft. It would spin up a locally running container that is serving as an MCP server. Also, there are other ways of spinning up local MCP servers, which is using a Node.js package or a NuGet package. So you could also launch an MCP server using these methods. So we'll briefly see how we can launch an MCP server locally using these methods. So this is an example of an MCP configuration. If you're launching using the NuGet package. So here you can see that it's saying that you use the .NET tool and you launch the NuGet package from this location. Um, and this is the way it is, the command will be launched. If you're using Node.js, you would be selecting this particular Node.js package when you're running it locally. Now, if you're using other AI-powered IDs like Claude and Cursor, then you might want to, then as I mentioned, you might want the Docker is the most preferred method where you're launching this particular image that is provided by Microsoft, um, and you're launching it locally on your system. As part of your environment, you might want to share your credentials. Alternatively, if you have used Azure CLI, You can also share the volume mount that we'll see shortly, where you are mounting the volume where your Azure settings are configured on your dev machine onto the container. That would allow your container to interact with your Azure account. And of course, if you're using VS Code, which we'll be seeing today later, you can use the VS Code extension, which allows you to install Azure MCP Server as an extension look in your VS Code, and that supercharges your AI workflows by exposing all the MCP tools that we have for your AI workflows. So we'll be seeing this shortly. So if you wanted to follow along, now would be a good time to switch gears and try the same exercises with me. Awesome. So let me share. So I have an Azure account here where I have a bunch of resources, and today we'll try to query these resources. Let's focus on the storage blobs for this session. So in this session, we'll try to query these blobs, and also let's try to load a new file and see if we can do that using MCP. So going on to my VS Code, um, as I said, um, we have this extension that is provided by VS Code. You want to install this on your system. So let's go ahead and install that. While it's being done, let's talk about the different configurations that we have. So as I mentioned, there are different capabilities that are exposed by the Azure MCP server. Like if you see here, these are the different services that we can interact with. Like we have the Kubernetes service over here. We have a bunch of key vaults. We have the storage server, a SQL, and so on. So if you want to, you can limit your interactions only for particular services. So this is a way you can choose if you want to limit your services. This The other configuration that we spoke about was the read-only mode. If you want your AI workflows not to make any changes in your Azure account, you would want to enable this setting. That will make sure your agents are not making any changes to your Azure account. Now, when you're launching the server mode, there are a bunch of tools and capabilities that are provided by the MCP server. These are more than 100 tools. Now, all these get sent to the LLM as part of the context. Now, as your context increases, the responses degrade over time. So if you want to be efficient with your context, you want to limit the number of tools that are being sent. So Azure has this mode where you can either expose all the tools one by one as part of the capabilities, or you can collapse them into a single tool. So basically, we'll be just sending one tool saying that this is a catch-all tool for all LLM for all Azure interactions. It will be routed to this particular tool, and internally it will route to the different capabilities. So these are different configurations that you can use to tune your MCP server. So going back, this is installed now. Uh, Another step you might want to do is you might want to log into your Azure account. This will make sure your MCP server can authenticate with your Azure account. So everything seems installed now. Let's list the MCP servers locally. So over here, we can see the Azure MCP server is running. We can look at the output over here. So we can see that the MCP server was started. The MCP client was able to connect with the local MCP server, and we have discovered 176 tools. Now let's try to interact using these tools. I'm going to start a new chat window here. So if you, this is the new chat window. When the, as part of the MCP connection, the client would have interacted with the server and listed a bunch of capabilities. So if you go and click the this tool icon over here, we can see all the capabilities that are available to our AI workflow. So over here, we would see the Azure MCP server. Under this, we would see all the different services that it can interact with. And within each service, there would be a bunch of tools that is available. So for this demo, I have only enabled a bunch of services. Like we are going to see the storage interaction. So I've enabled the storage services. I've also enabled a bunch of services that allows me to list all the resources and the subscriptions. Um, Again, this is to make sure your contexts are optimized. Uh, if you enable all the tools, um, it might lead to context bloating that might degrade the performance of your LLM because a lot of information is being sent. So you might want to be selective when you're choosing tools for your workflows. Once that is here, let's try to play with the Azure account. So let's see, let's resources in my subscription. Awesome. So we can see here it's interacting with the Azure MCP server. Um, and it ran this particular tool and it got the responses. So in my subscription, there are 4 resource groups. So let's hone down a little bit more and like try to find list resources in this particular resource group. So I'm trying to go and interact with the storage blobs. All right, so let's list all let's storage containers across all resource groups. Awesome. So we have found these 4 storage containers, and let's try to now list all the blobs in this in these containers. List all storage blobs in the containers. And you can see that for all these interactions, it is using the Azure MCP server. Awesome. So we can see that it was able to find these different files in the storage containers. Going back to um the storage container, these are the different files that we have. No files in this one, but if we go to our demo one, we could see all the files that are listed over here present exposed by the MCP server. Now let's try to create a file and upload it as well. So I'm going to minimize this. Let's create a new file called demo.txt. And let's see. All right. And now let's go back to the chat window. Upload. Okay, let's see. Let's create a new storage container. Create a new storage container called demo jan 16 and upload demo.txt over there. All right, so we can see that the action has been completed successfully. Let's go and peek over here as well, if we can see it. Okay, we can see the storage container being created and the file being present over here. All right, if you want to, we can, yeah, we can see the file being uploaded and the same contents being present. Cool. So that covers the storage MCP capabilities. If you want to, you can enable more things, like you can list your subscriptions, you can you can query your Kubernetes clusters and get more information about your Kubernetes cluster. So yeah, feel free to play around with this. Now switching gears, if you're using a different cursor, different ID, uh, this is, as I said, you'd probably want to use Docker um, as a recommended method. So in this case, I'm switching gears and I'm moving on to Google's anti-gravity ID. You would see here that I'm launching this image, the Azure MCP Server image. Over here, I'm mounting the volume, which is mounting my .azure of directory onto the container. This basically allows my MCP server to interact with my Azure account. Um, Now, this is the raw MCP config over here. And if we refresh the MCP server, we see that these capabilities are now available for my AI workflows. These are the same ones that we saw in the VS Code as well. Over here as well, you can select which ones you want to select and or choose. Now let's try to list some resources over here in my Azure account. Now, one catch with this is there's a bug issue with the latest MCP server, uh, where the responses from the server in the Docker mode is being is incorrect, but hopefully they fix this soon. Okay, it's not using the MCP server. Yeah, but if you look over here, this is currently the latest version is broken. Uh, this is a known issue, but if you have to use an MCP server in a different IDE, you would use it in this way. Right. So going back to VS Code, so this is how you would interact. That covers the VS Code session. And that covers almost the entire agenda that I had. Uh, Let me know if there are any questions. Again, like thank you for having me. Thank you for listening in. I'll stay around if you have any questions for me. Otherwise, thank you so much.